Okay, so question number 7. On the weak acid, strong base titration curve shown below, label the following points. A, the point where the pH corresponds to a solution of the weak acid in water. B, the point where the pH corresponds to a solution of the conjugate base in water. And C, the point where pH is equal to pKa. Okay, so let's try to write out the same graph. We have pH, the solution, graphed with milliliters of titrant. And then 7, like in the middle. And then graph kind of looks like this. Okay, so this is kind of what the graph looks like, and we just need to label A, B, and C. So I'll just show that when we have a titration of a weak acid with a strong base, our titrant is the strong base, which is found in the burette. So this is the volume that you're adding to titrate the analyte. In this case is the weak acid, and this is found in the flask. Okay, so option A, the point where pH corresponds to a solution of the weak acid in water. So this tells us that no base is added yet. So this is like the beginning of the titration, and pH is at its lowest, since acids have a low pH. So this tells us that point A is found right here. And now let's look at point B, the point where pH corresponds to a solution of the conjugate base in water. So this is when the value of the pH is greater than 7, and when the slope is at its maximum, and this is also known as the equivalence point. So the minute the titrant completely titrates with the analyte, then we have a solution of the conjugate base in water. So this can also be shown on the graph as the equivalence point, which is in the middle. And then for the last part, the point where pH is equal to pKa. So when the pH is equal to the pKa, then the volume of the titrant is half of the equivalence volume. So in other words, the volume of the base is equal to half of the equivalence volume. So the equivalence point I mentioned earlier is where point B is. So when we have half of that value, then this is where pH is equal to pKa. So it's like around, okay, like around here is point C. Okay, so let's see what the junior tutor said. The titration curve is given. Titration curve given is a titration of a weak acid to a strong base. In the first part of the titration curve, it is predominantly composed of the weak acid since strong base isn't added yet. So they showed A at the lowest pH level. The next point is the pKa value of the titration curve. So they did part C. Next, pKa value is defined to be the halfway before the solution neutralizes. Okay, so they showed point C. The center point is called the equivalence point where the pH neutralizes. The neutralization still happens at the next point until the last point where the strong base becomes excessive. So they just showed, so you can also have B up there, but if we wanted like the actual point where the solution, where it corresponds to a solution of conjugate base in water, we can also just show that at the equivalence point. But yeah, they showed where if you had excess base, then you would just have a solution of conjugate base in water. I guess it just depends. So this solution is correct. I'll just note that point B can also be shown as the equivalence point. Once the pH value is greater than 7.